What's up? Let's do some 3D stuff. Yeah, I figured I wanted to learn some more graphics programming. So this is what we're gonna do. I've got some stuff going on here on the left. This is ray tracing. It's going for like a Windows screensaver kind of vibe. Lowered the resolution, added some anti-aliasing. I think it looks pretty good. And it's running on my GPU at 120 FPS. I'm pretty surprised that it's actually running pretty well. Although it's not that bad, there's only 3 objects on the screen. I guess technically 4. This is cool. This is my first time successfully ray tracing. We've got little reflections, we've got some lights, shadows. It's pretty cool. This is the code. I didn't realize that I accidentally posted this publicly on ShaderToy. I thought it was private. I realized because someone left a very nice comment giving me suggestions on how to improve it. Now, I don't exactly know what a Fresnel term or a Schlick's approximation is, but I'm happy to learn. Yeah, and I think, yeah, I calculate my reflections wrong. That was funny. I wasn't expecting to see this comment. Still very happy with it, even if it's not, I guess, accurate to real life. Okay, what I'm doing here on the right is not ray tracing. I'm trying to do some like traditional graphics by drawing polygons and stuff. Oh, hello, welcome. I might exist. Well, thanks for clicking and greeting, and I hope you have a good night. This is a chill stream. I haven't really announced it. I just wanted to learn some graphics. Anyway, this is what I'm working on presently. It's this like actual traditional renderer that's not using OpenGL. I'm just gonna draw some polygons onto a texture, try to make it look 3D. This is just a bunch of lines. So here's my plan. My plan is to make it a little bit faster because I think it's pretty slow for drawing 500,000 lines. I think I can make it faster. And once I make it faster, I'm going to start drawing some polygons. I downloaded some models and try to draw those. And I'm programming this in C. Alright, I'm drawing 500,000 lines, and it's taking almost a second. Which is kind of slow. Although most of that might be spent right here, deciding where the position of the line is going to be. Alright, whatever. I turn on optimizations. It makes it almost 3 times faster. That's pretty good. That's actually a huge difference. I think I can squeeze a little bit of optimization out of this, regardless. Oh, it's still running at 0.3 seconds. Alright, 0.9 seconds. To draw 500,000 lines. I'm trying to think, what's the beefiest part of this code? Maybe this if statement? I don't know. I feel like if it's anything, it's these if statements. Alright, you know what? I'll make it faster later. Let's just draw some stuff. Okay, let's try drawing like a wireframe of a 3D model. Nope. Oh wow, it actually guessed what I wanted to do. That's pretty good. Yeah, just let me type it out. Okay, let's pull out a triangle. Good morning, Arctan. How you doing? We pull out this triangle from this list, which is 3 vertices. And then I want to draw a line between each of the vertices. First vertex X, second vertex Y. Not gonna use that. Get rid of all this crap. So I'm basically just gonna ignore the Z position. Oh, and I also want to map this to screen coordinates. So right now the model is, I think it's normalized between -1 and 1. This is just for fun. I wanted to learn more about 3D graphics. Just kind of teaching myself. Okay, let's convert these positions into screen coordinates. What's up, Tim man? I like how it's morning for you guys. Right now it's midnight for me. Alright, I'm gonna make a new file. Vectors. Oh, it's 3:24 a.m. Yes, the very early morning. I'm a morning person. Very early morning person. Yeah. Alright, get all that stuff out of the way. Yeah. Okay, so what am I doing here? All these vertices are between -1 and 1. And I want that to be between 0 and width or height. Yeah, I could do that, or I could just say add 1 and then multiply. By width divided by 2. No, that's incorrect. Get all this vector crap out of the way. Alright, do the math, we transform it, we add 1, divided by 2, we multiply it by the size of the screen. I'm going to do that 2 more times. Beautiful. And then, yes, reassign it. Okay, so we do all that. Now we're gonna draw a bunch of lines, triangles. Second line. And the third line. Alright. This better look good. This better look like something. It also might crash. There's a high chance this will crash. But we're gonna find out. Just delete some stuff. Get rid of that. And it crashes. Okay. Let's see what we did wrong here. Here. Let's just see how many triangles we're able to draw before it dies. 0 triangles. Okay, now we're gonna do my favorite thing, which is println debugging. Print debugging. Just gonna keep moving the print statement until we find out where it dies. I could use a proper debugger, but you know how it is. Oh, this one doesn't even make it to the print statement. That's awesome. Oh, you know what I never did? When I load this model, I just never set the data. I just gave it garbage. Look at that. That ain't garbage. It's upside down. Oh, that's funny. I'll let you guys try to guess what this is supposed to be. Wahoo. Yeah, it is upside down, huh? I can just do this. Wait, that's not gonna fix it. I wanna just flip all the Y positions. There we go. Alright, that's pretty cool. That is something on the screen. Okay, I think what I want to do next. I mean, I can go two ways here. I can either add a camera and rotate all these triangles around, or I could try filling in the triangles, give it some color. Ah, you knew. It's Star Fox. Actually, you could probably tell because I have a file named airwing. So I think the route I'm gonna take is try to fill in the triangles. Triangle. Alright, how do I want to do it? Yeah, I guess I'll just take 3 points. Okay. Here's where I'm gonna need some help. I vaguely know how to draw a triangle. Yeah, it's something like this. Just do whatever this is, and then you have a triangle. Yeah, honestly. Whenever I see a notation that looks like this, I die a little bit. This is definitely university lecture slide notation. Unreadable. Okay, so I think I know what you're supposed to do. I think I know what you're supposed to do. I have an idea. I'm just gonna take a wild swing at this and see what happens. But I'm gonna sort the positions, the points, by their Y position, their Y coordinate. And then try to draw a line from topmost to the bottommost one. What's up, Garto? Yeah, I'm getting myself into something. But if you haven't seen this yet, look at this. We got a wireframe. We got a 2D wireframe of a Star Fox model. That's not bad. Not bad at all. Okay. Here's what I'm gonna try to do. I'm gonna sort my vertices. Oh, look. The code completion knew what I wanted to do. Sortices. Sort vertices by Y position. Honestly, I think I'm gonna turn off code complete because it's very distracting. And it's not helping me learn. Yeah, disable completions. Yeah, we're aiming for not absolutely tremendously bad. That's our goal here. All right, let's do this the stupid way. We sorting. We're gonna do some devious sorting. Yep, that's right. Okay, if V1 Alright, how do you sort anything? You just swap the last two. And then swap these two. Beautiful, beautiful thing. Okay, if this guy is lower, this guy is higher up than this guy, we want to swap them. Actually, let's make more functions. I need more functions. At the function. Yeah. Do a little bit of this. That looks pretty good. Isn't that something? Isn't that just something? Swap. Okay, awesome. Now we just do the same thing here. Swap the boys. Alright, easy. We need a little more executive function in our lives. Alright, now our ducks are all in a row. So let's do whatever this diagram is telling us to do. It's telling us to do something. So I'm going to try to draw a line from this top point to this bottom point and walk along it Y position by Y position. So let's just do a little bit of this. Basically, the first 2 points are going to be the long leg. Above the triangle. It's a Bressenham with a step right. Is Bressenham the line guy? Yeah, this one. He did triangles too. He moved on from lines onto triangles. That's crazy. Okay, that is not what my line algorithm looks like. He did both. My line function is so much more cursed. I don't know what this is. And I have 2 for loops. He just did it. God, Bressenham. Bressenham goes nuts. This guy. I want to be a little more like him. Why is it always triangles? Triangles are the best shape. Maybe not like the coolest shape. Or the most moral shape, but they are the most functional shape. Alright, and now I want to sweep. I want to sweep from left to right. Which means I need a point on the long leg. And then I need to find a point on the opposite leg. Controversial take, rectangles are your favorite shape? So you mean 2 triangles are your favorite shape? Is what I'm hearing. It just sounds like you like triangles even more than the rest of us. Rectangle is 2 triangles. So I have a Y position. I need to find an X position. Too much X position. Okay, if I have... Dude, how do you do math? Does anybody remember how to do math? Sometimes I just write down the equation for a line and hope that something comes to me. Yeah, I kind of forgot math. I have a Y position here. I need to find an X position. We're in the X position phase. I'm just gonna solve for X. That usually works out. Okay, that's not so bad. All right. I did this up here. We're gonna have triangles yet. Right, yeah, I do a regular line algorithm. And then just fill between them. Right. Easy. Easiest thing I've ever done. So I take this guy, which is this plus a lot of stuff. Y minus v1.y times this thing. Okay, we got our first x. Beautiful. Let's just put something on the screen and see what happens. Excuse me? Oh yeah. Integers. Yeah, trying to cut out my X. Oh, beautiful segmentation fault. Let's make sure that everything's still on the screen. I'm really crashing this way more than I should. Not being careful. Oh yeah, of course, because our x is negative a billion. Yeah, of course. Okay, first of all, I don't need to cast this. Pointless. Now why would it be negative a billion? That's my question. Actually, it's negative 2 billion. Okay, so y is normal. This is 0, this is a number. Let me do the thing. Yeah, it's probably all that pointer garbage I'm doing. Although that doesn't make any sense. You know what? Yeah, it's probably all messed up. Let me look at all my vectors. Okay, at least the first two vectors survived. Did I destroy it? Oh, I really did just do it by hands, like I could have. Thank you for pointing that out, actually. Sometimes I just do things the really slow way. Okay, actually, I'm really surprised that this X value is garbage. This, you know, this number could be garbage, actually. It's probably like nan or infinity, and I'm trying to convert that into an int or something. Yeah, it's infinity. Okay, cool. Which means whatever numbers I put in here are trash. Yep, they're trash. Okay, let's draw a better triangle. That doesn't have any horizontal or vertical lines. Here, what are the best triangle coordinates? This number. A little bit to the right. A little bit down. Yeah, that's a good triangle. And then let's just move these around. Okay, cool. We have a line. Nice. Here, let me hide Star Fox for a second. Sorry, Star Fox. Yeah, that's beautiful. So we draw a line, and we only draw once per Y position. Beautiful. That's sick. That's freaking awesome. Okay, so we just gotta do the same thing, but for the other two triangles. And we gotta find out which is the other leg that we're looking at. And that's pretty easy. Just ask if Y is less than. What am I thinking here? Actually, I want to go all the way down the third point. Yeah, that's what I want to do. Because the second point is in the middle. So let's do this. We're gonna draw this leg. This top leg on the right. And we basically just do the same thing, but we need to do some math here. And the points involved are... Actually, a lot of this is wrong. There we go. That's correct. This is correct. So we want to get the point on the other leg. Basically just do all the same stuff here, I think. Where are the tiny men? You mean the little guys? They're hanging out. I just released a new update, like yesterday or the day before. It's the little guys game. I made it a lot faster. We're all tiny men. Listen, if you're under 6'2", tiny man. That's the rules. So we get this end position here. End X. End X. Wish I could, you know, whatever. Yeah, I'm just making up numbers here. We're gonna find out if it works. Okay, now let's sweep. We're sweeping. We're gonna do what Bressenham wanted all along when he invented triangles. Okay, but we have to swap the start and end positions. And also cast everything to an integer. Yeah. Classic. We're doing a lot of swapping today, I'm realizing. Alright. Cross our fingers and pray. That's a triangle. Let's go. Oh, beautiful. See, this is graphics. You're telling me this isn't graphics? This is graphics. This is graphics happening in real life. This will be graphics in 2013. Alright, now of course there's edge cases. I'm debating whether, like, will it just die if I try to draw a triangle that's like 1 pixel thick? Yeah, probably will. Okay, let's draw a triangle where the bend is going the other direction. Let's just do a couple edge cases. Some edge cases, maybe some corner cases. I gotta come up with a new triangle though. X. Whatever. There. Alright, yeah, that's probably something. And look at that, the bend's going the other way. God damn. That's triangles. Also, do you like how I'm using 4-bit color? There's literally no reason. I was like, fuck it, I'm gonna use 4-bit color channels. 16-bit color. Who cares? Why not? Also, transparency just doesn't work. There's no such thing as transparency. I guess I have to implement that myself. Yeah, whatever. I'll add some blending modes. But yeah, we gotta draw some stupid triangles. I guess in mathematical terms you would call these degenerate triangles. But I wouldn't be so mean. Degenerate cases. Mathematical term. Okay, so it does crash if I try to draw a stupid triangle. In fact, we get a segmentation fault. What am I even trying to do here? So, here all the Y positions are the same. So honestly, I could try to be clever, or I could just say, if the Y positions are the same, draw a line. Yeah, just don't even give them the time of day. Just draw a line. Let's try another degen case. Vertical line. How do you do that?
Like that.
Yeah, vertical line. Whatever. What does that look like? Okay, we got vertical lines. You know, that is a good point. We could just not render it. Actually, that is a really good point. Why bother drawing an infinitely thin triangle? That's such a good point. Alright. I like that solution, actually. Well, hang on. Let me just make sure that... Like you said, we can have a horizontal base. A horizontally based triangle. X 100, X 400, Y 100. What? Why does that work? Well, that's nice. That's really nice, actually. Beautiful. Okay, yeah, let's just not draw. Let's not draw it if all the Y positions are the same. Skip. Yeah. Wow, who knew it was that easy to draw a triangle? Who knew? Yay, it doesn't die. Okay. Great, so we memed a bunch of triangles. Now, let's try to draw our wireframe with triangles instead of wires. If I want to use a different function, I'll just make a different function. Isn't it 2 or more of the Y or X positions are the same? Isn't it if 2 or more of the Y or X positions? Oh yeah. Wait. If only 2 of them are the same... Hang on. There's more edge cases. Making me be thorough. Okay, yeah, we'll try a couple more. We'll try 2 of the X positions being the same. Beautiful. Beautiful. No, this is good. This is good. Because I've been missing a lot of stuff. I'm actually very happy to have some people very interested in rendering stuff. I love this. I know it's boring, but I find this stuff fun. Get to draw cool stuff. Yes, the final degen case is this. Like, I could check for this. I'm just not gonna bother. I'm not even gonna check for it. I'm just gonna let that happen. I'll know something's wrong if I get a segmentation fault or if things look weird. But I'm gonna speed ahead to drawing this model. So instead of drawing lines, we draw an epic triangle. Oh no. Sorry, I just brushed the mic. I forgot that in C, the order you define functions matters. Unless you have a header. Should add a new file for drawing stuff. Alright, yeah, new file time. What should I call it? Render? Raster? I'll call it render. Alright, so what do we got here? We've got a whole bunch of little functions. We can draw lines. That's neat. We have 16-bit color because who cares? What else can we draw? Oh, that's gonna be a problem. Alright, I'm just gonna do this for now. Yeah, we're gonna take all this, put it in here. Sorry, no one wants to watch me organize code. It's okay, it'll take 2 seconds. Why did I make so many functions? What am I doing? Should have just put everything in main. I'm a fool. Playing Medieval Dynasty. Love Medieval Dynasty. I like the name Blizzbor, but honestly, Bullslaw kind of wins among the two. You should definitely go for Bullslaw. Good choice. Include render. Render.h, don't need that. Okay. Sorry, I'm just scrolling back and forth. It's probably very disorienting. I don't want to give people motion sickness. Okay. Filling a triangle. What happens there? We have some pixels. We do got some vectors. Thank God. And then a color. So I'm gonna color it by the depth. Now technically there is no depth. Because we're just flattening. We're just projecting the model onto a piece of paper and ignoring the Z position, which is awesome. But yeah, let's choose a color based on the depth. So what I want to do is let me think here. We have 3 vertices on a triangle. I didn't actually think this far ahead. Because the depth of a triangle changes. Yeah, I'm just gonna do it the stupid way. Motion blur plugin for my ID. Oh, that would be awful. Please do that. That would suck. Please do that. Alright, here's what I'm gonna do. This is just for demonstration. I'm not gonna worry about this too much. We're gonna take that Z position, just a random Z position from the triangle. Or I could just average all of the Z positions. Why not? This is just for demonstration. Hello, okay. Welcome. You're in for a treat. Hope everybody's ready for their treat. Okay, I'm gonna take this number between -1 and 1 and turn it into a number between 0 and 1, and then multiply that by freaking 16. And then cast that to an int. And then see what happens. Alright. Yeah, get rid of that. We gotta include stuff. And still some issues. This is defined here. What? It's lying. Why is it lying? Oh, you know what? I think there's some weird stuff I have to do. Alright, we're using macros. Hate to say it. Oh wow, that's awesome. Okay, it's still dying. And segmentation full. Yay. Okay, let's just make sure the wireframe still exists. Okay, we still got the wireframe. There's so much untapped potential for IDE rendering. What are we doing? I love how this is still causing a segmentation fall. Let's see. Let's see if... Oh, you know what? I don't do any bounds checking. Like a madman. I don't do any bounds checking. That's crazy. I'm going nuts over here. Literally no bounds checking. I love C. I love programming in C so much. Just makes me feel more grounded, that's all. So all of our X and Y positions are stupid. Because these are integers. I'm a fool. Oh, yep, saw some negative numbers. Oh yeah, a lot of negative numbers. We're just writing to random memory. That's awesome. What's this? Okay, let's just do this the awesome way, and... you know... you know how it is. Yeah, classic. And then... ends y v3.y. Sometimes you gotta check your boundaries. Yeah, that's beautiful. Can't just draw triangles willy-nilly. Oh, dude, I killed my terminal. I printed too hard. Do I have to restart VS Code? I think I broke it, actually. Oh, no, we're good. Maven. Yeah. Not at work. Yeah. Okay, we're still seg faulting, which is pretty cool. Still dying. We go there. And Y. That's freaking awesome, dude. Okay, let's just make sure we can draw a triangle that's, like, larger than the screen. Like, if I say negative 100, what's gonna happen? Who knows? Negative 100. Yeah, I don't know, negative 200, and then... I don't know, 500. Then X, 500, 300. What's gonna happen? Okay. It's a darker color. Try to not flashbang you guys. Okay, big triangles, big triangles. I like it. Yeah, big triangles shouldn't be an issue. Love big triangles. Yeah, let's just make it massive, I guess. Maybe the triangle function is okay. All of this should be okay, because we can still draw the wireframe, I think. Yeah, we still got the wireframe. Got that on lock. It's just when I try to fill a triangle here, it will die. Alright, more printf debugging. This is what we were made for. Yeah, and let's do this thing. Okay, so we have a lot of very normal numbers, although that's kind of sussy. That's not good. V1. You know, maybe there was an edge case that we did not consider. It dies trying to draw this triangle. That's very interesting. What could it be about this triangle? Well, let's see. Oh, wow. Okay, you were onto something. Two of the points are the same. What does that mean? If I have a triangle and two of the points are the same, then that's also a degen case. Okay, I gotcha. You warned me about this. You said you told me this very thing. I did not listen. Yeah. Ugh. So well, it's not, this can't be an or, because I can have a triangle that has one completely vertical leg, and the other point is somewhere else on the screen. Like, is it enough to just check if any 2 points are the same? Well, no, I think we're onto something. So I'm gonna check here. I'm gonna add a function that checks if 2 points are the same. Standard Boolean, because we're Boolean. Equal. Vectors. Okay. Ish. I love using double equals on floating point numbers. It's just so natural. You do square magnitude check for each edge. Ooh, that's true. But multiplications, though. I'm doing this on my CPU. I gotta save all my clock cycles. I get so jealous. I read through the graphics subreddit, and everyone's like, my custom renderer runs at 400 FPS, quad-core, multi-threaded, real-time reflections. And I'm like, I want to do that. Yeah, Nolan, this is all for my Subway sandwich simulator. Yeah. I was trying to make it in a loser game engine. But it was just wasn't working. Turns out rendering Subway sandwiches and just is too powerful for any normal game engine. I had to do it myself. Start from ground zero. I like to think of programming as making a Subway sandwich in a lot of ways. They're actually quite similar. Alright, let's just see if it dies. Okay, cool. Please work. Please work. I beg of you. Please work. Alright, that's something. So, there's clearly some problems here. I mean, the most obvious one is there's no depth handling. I don't sort my triangles. But, I mean, we can sort them. Let's start by sorting the triangles and then, you know, do something else. fix whatever those horizontal lines were. Yeah, Nolan, you're right. It can only be appreciated on DOS. You just don't get that kind of sandwich fidelity on modern systems. Where's qsort? stdlib. Love me some qsort. Alright, we're gonna do a quick sort. It's gonna modify the models list, or it's gonna literally modify this model, which is absolutely not what any reasonable API would do, but this is just for debugging, so I don't care. Now actually I have to figure out how to use this qsort function. What do? You give it an array. So I'm gonna give it the triangles. Actually, this still isn't gonna work because there's no clipping. It's just gonna draw entire triangles on top of other triangles. Render reordering the models. Yeah. I wish this is what graphics APIs actually did. I wish they would optimize my assets for me. How should I... What should I do here? I have to do clipping. I have to know what the depth of a triangle is at every point. Okay, so when I draw a triangle, I have to use my brain. When I'm literally every pixel of the triangle I draw, I have to think about the depth at that point. Don't tell me I have to use my brain for this. Oh, my poor Star Fox. Poor guy. No, I don't want to. I don't want to think about frustums. No, scary. Too scary. No. See, that looks so nice. What's with these infinite triangles? Why are they infinite? Very aesthetic. Oh yeah. Okay, you know what we could do? No. Actually... Okay. I'm gonna do something for fun, but not for progress. I'm gonna have a little bit of fun here. Yeah, it's another degen case. What am I trying to make? The goal is to make 3D. I'm trying to make 3D happen. What I'm trying to draw is the Star Fox spaceship. You know, this guy. I downloaded a 3D model of this thing and I'm trying to draw it by hand. Look at that. Okay, I'm gonna have a little bit of fun. Don't sue me. Let me just try to remember my linear algebra here. Yeah. I'm being stupid right now. I could fix the renderer, or I could just do something stupid for fun. Actually, it actually might. This might actually end up being useful. But we'll see. V-rot. We're rotting from the inside. I may not understand how clipping works, but I'm pretty proud of myself that I can remember how to do 2D rotation. At least I have that going for me. this time I'm not going to mutate the the model that the user passes in. I'm not going to be an insane person. Vec3. And then T is a float this once. Excuse me? Incompatible with parameter of type float. What have I done? C is being weird. Why is C being weird? Why are you being weird, C? Argument of type triangle. Incompatible with parameter of type float. Yeah. Do I already have something called T? I do. That's why. Alright, just run it, see what happens. Clear the damn screen. Of course. I should have known. See, that's 3D. Oh, you can kind of see Star Fox's head. Okay, his name. I know his name isn't Star Fox, but whatever. So, I know it looks 3D, but this isn't 3D. This is fake 3D. This isn't real. This is a, what's it called? Orthographic projection? You know? Still. Looks cool. Yeah, I just need a projection matrix. Ugh. Okay. Pretty cool. Pretty cool. Hey, 2 hours ago, 1 hour and 40 minutes ago, we could barely even draw a line. Okay, yeah, let's draw. let's draw some triangles. Let's fill in our triangles. It's probably gonna look like garbage. But you know, that's fine. Let me switch this out. Fill the model. Okay. Not as cool, that's for sure. Also, why is it... It's drawing like a tiny white line.
I don't understand what's going on here.
So it looks like these horizontal lines are just any horizontal triangle. Should I rotate the triangle in 3 dimensions?
I don't understand what's going on here.
Give me a break, give me a break.
Dude, yeah, I don't know. Okay, so technically what I'm doing, I'm kind of reinventing a 3D rotation, but I'm just cutting it up into 2D components. Let's just tilt it like a little bit, like a few radians. Wrong function. That's it. Oh wow, that did nothing. That just destroyed it. I have to do the vertical rotation last. Oh, wait, no, because I'm not using the right value here. That's why.
I don't understand what's going on here.
My brain literally can't process what's happening. Let's do it in a different order. Okay, there we go. Oh, that's funny. I tilted it, but it, like, compressed it. Okay, let's not worry about that. I'm getting hung up on, like, weird things. I don't know why. But yeah, let's just focus on what matters. Horizontal lines. So let's just fix that. Let's go to the triangle function. And it doesn't like those horizontal lines. So, I mean, that's just gotta be kind of the same as this other degenerate case. If all the X positions are the same, like, don't even draw it. But that doesn't fix it. 1, 2, 2, and 3. I'm gonna do something pretty radical. What if I, like... No. Yeah, you're right. We should hone in on this. Okay, here's the plan. We're gonna fix this weird horizontal line issue, and then probably figure out like proper depth and clipping. And then maybe we'll do a projection matrix or whatever and actually see it in real 3D. How do you define something as 3D or fake 3D when it's viewed from a 2D screen? Wouldn't that mean everything digital is also fake 3D? Yeah, I mean, yeah, everything on a computer screen is fake 3D, technically. When I say what I'm drawing is fake 3D, it's like, I'm not actually drawing it the way your eyes would see it. I'm drawing it if you didn't have any depth perception. That's what I mean when I say it's not real 3D. X. Okay. You know, I could just look at the object file and see if there's anything where, like... No, that's too hard. Too hard. Let's try some weird cases. What if, like, one of the lines on the triangle, or one of the points is like a pixel off from horizontal? Oh wait, this isn't horizontal. It's the opposite. The opposite of horizontal. Okay, doesn't render. Nice. Let's move one of the pixels. Ooh, that's weird looking. But I think that's okay. That's fine because it's trying to draw a triangle with a flat base. And it just kind of sucks at it, but that's still okay. I'm okay with this. Here's what we can do. Let's just move this point. So we get -1. Yeah. Nah, nothing. Oh, right, because I have to put it inside the... See, this all looks okay. I love how there's just one pixel at the end of the triangle. That's like, I'm here. Gotta fix that. So these look okay. Now let's try... You're telling me my triangle drawing algorithm isn't perfect. Clearly this one pixel's intentional. Nah. We'll fix that too. All of these triangles are chillin'. They're all chillin'. Isn't that something? Yeah, I wonder too. It seems like it's happening in weird horizontal situations. What else? Let's try some right angles. You know? I bet a good right angle could really just mess this up. Right angle exhibiting literally a corner case. How do I want to do this? Let's think of all of our favorite right angles. Let's do X and Y at this point. Something along the same X but higher up, and then something along the same Y but to the left. Okay. Now here's the crazy thing. We do sorting on the Y positions, so... I wonder... if the order matters here. You know, at the end of today, at least we'll have some good-looking triangles. And that's really all you can ask for. Okay, let's draw these in different colors. Make sure we just got 2 triangles going. Okay, I'm gonna move these vectors around and see if the sorting is messing it up at all. Will this stream be on tomorrow? Yeah, I could do more tomorrow. Just kind of doing this casually. My main project is the little guys game. This is just for fun. Okay, let's try a different right angle. Instead of having this be our corner, let's do this. Wait. Well, I am getting a... Well, it's not that the swap function is wrong, it's that when I have Y values that are the same, the rendering is going to be different depending on the order you pass them in. Because they either will or won't get swapped. Thanks, okay. Yeah, thanks for stopping in. Dropping by. Be surprised if I was getting right angles. Yeah. Grasping at straws here. Although I did just get a segmentation fault for no reason, which is awesome. So we gotta fix this case. The goal is no segmentation faults. So this is interesting. This is a right angle triangle, right? We got this top left position, and then goes down and goes to the right. Wonder if the order matters. The order matters! Oh no. That's so sad. Yeah, I want to draw this. Top right gang. Or no, top left gang. But if I change the order of the vertices, it dies. So the sort function... First of all, I'm gonna move this. Yeah, we're making progress. Although, it might not solve the problem we were trying to solve, but you know, at least we're fixing something. The triangle wireframe is okay because that doesn't call the fill triangle function, it just draws lines. This is crazy. So what would it be doing here? It would be, when it sorts them by Y position, first it tries to swap these two. Oh, dude. I don't know how to sort things. Hang on a second. if you give me a list that looks like this, and I swap the last two numbers, and then I swap the first two numbers, it's still not sorted. Ah, god damn it. I have to do one more check. Ah. Beautiful. It was not sorted. Yay! Triangle. I'm getting a lot of warnings, which is awesome. Okay, to reward myself for fixing that bug, I'm gonna get rid of these warnings. Ooh, that's awesome. Vector 15. Oops. That's awesome. Haha, no printf. Alright, we're good. Alright, let's try drawing the frickin' thing again. I bet it just did not help at all. Okay. Completely separate issue. Let's try just a couple more cases here. Let's do... I'm gonna take my point at here, drop it down to here. That's good. Wait, hang on a second. I love Kotlin. And is that all the triangles? Actually, I think we skipped top right gang. Let's move which point? X, Y. Yeah, we're doing okay. Okay, so here's an idea. The Star Fox model only has like a couple hundred polygons. Not even a couple hundred, like 130 or something. So what if I was just like, let's draw a few of them. Yeah, we're gonna narrow this down for sure. This is what I call a binary search, but you start at 10. There we go. We've narrowed it, almost narrowed it down. I think it's this one. Wait, what? Is this one triangle? Oh no. Am I drawing... Is this one triangle? That's awful. This really be one triangle? Yeah. I see, okay. The positions are very close. And it's freaking out. Okay. Yeah, I can work with it. That's interesting. Almost. Just ignore that. No. I just didn't copy it correctly. There. Yeah. There's our culprit. Look at that. Alright. So what is it trying to do? It's trying to draw a vertical line between here and here. And then just at that top line it freaks out. It's freaking out. So let's just debug this like a crazy person. So it does that on the first horizontal line. It just keeps drawing for no reason. So we narrowed it down to this triangle. It's a case where These two Y positions are so close, but not the same. Pretty wacky. And it happens on the first line of the triangle. It just freaks out. Just chooses like the worst starting position, I guess. Why would it pick a position all the way over there? This is going through the line drawing function first. So this doesn't use the line drawing function. The triangle function is separate from the line drawing function. Yeah. That's so bizarre. So this is just the first line of the triangle. It just doesn't want to draw it in the right position. So what do we have here? We have this spot. That's okay. That's messed up. It didn't look like it was going off screen. It just looks like that top line just extends out way too far for some reason. Zip. Oh yeah, it probably does try to go infinitely far. Zip. Why is it just that line? This makes me want to just skip drawing the first line. That's nasty. All right, I'll rubber duck the function. I appreciate you, Arctan. Alright, we got fill triangle here. Gives you a buffer of pixels. Doesn't tell you what the width and height is for some reason. 3 points for your 3 vertices on the triangle, and a color to draw it as. Got some degenerate cases here. This is a completely horizontal line. This is completely vertical. This is if any 2 points are the same. Skip those cases. Then we sort the vertices by Y position because I want to find out what the longest leg of the triangle is going vertically. So I want to start drawing line by line, starting from the highest point of the triangle down to the lowest point of the triangle. And then I compute the slope, or the inverted slope, of all of the legs of the triangle, which I need to find points on each of those legs. I start from the highest point of the triangle, and I cast it to an integer here, which means I just round down. Could try. I could just try rounding to the nearest pixel, which is probably much better and more accurate than always rounding down. Come to think of it. I don't know if that'll change anything, but it still looks kind of busted. We'll see. Yeah, still a problem. But, you know, rounding to the nearest pixel is probably better than always rounding down. So we start from this top position and go all the way down to the bottom position. And just as a safeguard, we only want to draw within the screen, the boundaries of the screen, so we limit our Y positions. And yeah, this is our start and our end pixel. We start drawing from here. And so the issue is happening on the very first line, on the very first horizontal line. Like, if I only draw the first line, we can see it get all fucky. So what is it doing? It gets the left, or it gets the position on the longest leg, the X position on the longest leg. Kind of just unwrapped the equation of a line. I take my Y position and I subtract. Maybe I should do start Y here. Yeah, we could try drawing the first two lines. Oh yeah, you're right. It's, well, actually, maybe. I can't tell if it's worse. Okay, so another thing I see that's weird is this is our pixel Y coordinate, but we're subtracting by the floating point Y position, so I may as well use start Y here. And it is still ass. I mean, maybe. What does this mean? So this just measures, like, the number of vertical lines we've traveled. Or the number of... Sorry, the number of horizontal lines we've visited so far is y minus start y. So this starts off being 0, which means... Well, hang on a second. For the first line, y is start y, so this thing is going to give us 0 times that slope, which means start x initially is going to be v1.x. Okay. Stepping down vertically for 1 unit and horizontally using the gradient. Yes. Right. That actually, that's a good way of putting it. That explains this very well. Okay, so we're using the first point's x position. So it's trying to start from this number. Okay, this actually makes sense. This is kind of making sense. Because it's always using that, the x position of that vertex. Hello, the whale milkers. Wait, sorry, the whale milker. Welcome. Just to quickly show you what we're debugging here. This is what we're working on. We're trying to fill in these triangles. Okay, so yeah, one of the points on the line is going to be one of the points of that vertex, which means the problem, this makes sense. The problem is this other point on this line here. So what do? We say y, we're asking if y is less than v2.y. Which is interesting because that could be smaller than... If we round it, it could be smaller than the starting y. Good grief. It's still kind of happening. Okay, anytime I like compare or do math between these pixel coordinates and these vertex coordinates, I'm just gonna round. I think that was it. I think the whale milkers blessed us with their presence. Okay, I think that was the issue. We were like... I think we were just conflating these pixel coordinates with these floating point vertices. I think that was probably it. Well, thank you for forcing me to Rubber duck. I should have. I should do it more often because that actually was very helpful. I tend to just shotgun debug sometimes. This was good. God damn. This was very good. Thank you. All right. Let's draw that Star Fox. Make sure I'm not printing. For every vertex. Excuse me? Oh, I'm clearing after that's awesome. Yay! Okay. I forgot I have to change this back. Gotta draw all the triangles. Thank God. We did it. We did it. So, still no depth. 0 depth at all. But we're drawing the triangles in an orthographic projection. There's that one triangle, there's that weird white line it's drawing for no reason. Is that a triangle? Does the model have a really tiny triangle right there? I think it does. That's so weird. I'm gonna investigate that white line. It's so weird. Okay, it's this one. What's your deal? Who are you? Where do you come from? Why does it look like that? It's probably okay. I just don't know why the color is white for no reason. It's kind of the... Who do you work for? Oh. Okay, well, that makes sense. I made an assumption about what Z values this model would have. I thought it was all within -1 and 1. That's not the case. That's fine. I can just clamp my color here. Is there a clamp function? C clamp. That's not what I wanted. Why did it? Why when I search for C clamp it gives me 90 recommendations for a, yes, a C-clamp, but I don't need, I don't need to walk through Home Depot just to, oh, it keeps going. What happens? Where's my, what? It's all Home Depot, what happens? What's going on? How do I go back to regular Google? I don't. That was awful. That was so. That was disturbing. I didn't like that at all. Alright, we're just gonna make our own clamp. Jesus Christ. Good grief. Back to normal. Numb triangles. Nice. Okay, instead of doing it like that, why am I doing it like that? That doesn't seem right at all. Feels good to knock out all these bugs. There's a little bit of depth going on. Not really, though. So, okay. No more of this crappy, god-awful fake projection. Let's try something real. But first, I have to know what clipping is. We're gonna read the books. Yeah, this guy. It's gonna get real bumpy. So what does this guy do? He like... Dude, I can't read your math when I'm in dark mode. Why does his triangle function look way better than mine? Whatever. So I'm trying to do something like this. Well, I am doing this. Yeah, okay, this is where I am in life. I'm drawing all the triangles completely flat, no depth. Oh, I need to know what the normal of the triangle is. Do I want to know what the normal is? I feel like this is just like lighting the triangles based on the normal, but not doing any depth detection, I guess. Or maybe it is. This tutorial feels incomplete. Iterate through all pixels of bounding box for triangle. For each pixel, compute its coordinates. Outside the triangle. Yeah, barycentric coordinates. Drawing triangles outside the screen. Okay, no, this is still drawing triangles. Draw model, empty, blah blah blah. What's up, FixFox? Welcome. Let me show you what we're doing. We're trying real hard to make 3D happen from scratch. We're not quite there. Blah, blah, draw through. All the triangles. World coordinates, screen coordinates. Yeah, okay, this is what we're doing right now. This is definitely what we're doing. There's all these weird triangles here that are overlapping. Yeah, I think we just invented a new aesthetic. Alright, yeah, I guess I'll just... Backface culling. Oh. Oh, that's genius. Okay, that's why... Alright. I think I know why this one looks better. It's because they're calling the triangles that are facing away from the camera. Okay. Wait, how? Oh, because they have the normal data. Okay. Duh. Okay, let's do that. We have the normals. They're in the object file. That's, I think this number. So what do I want to do here? Hang on, I need to look up the object file format. VN is the vertex normals. Wait, do I have to do math? Are you telling me I have to do math? Like, when I color a triangle, you give me a triangle, I want the normal of the triangle. Yeah, face normals. Do I just take the average of the vertex normals? Or I mean, I guess I could just make a plane out of the coordinates. Use the vertex order. Wait. I think I'm misunderstanding what the vertex normals are supposed to represent. It's the normalized average of the surface normals of the faces that contain that vertex. Mainly for lighting calculations to determine edge hardness. Now, okay, but what this guy is doing is they're getting the normal of the face. Oh, they just like did the math. They're like, we have these three coordinates, let's just do the cross product or something. I feel like that's what they're doing. Okay, I'm gonna ignore the vertex normals. Now I know what you mean by the clockwise thing. That's what they were doing. Okay. It's all coming together. Now I have to make a dot cross product. God damn it. Wait, so does that mean that... vertices are stored in a certain order? Making explicit declaration of face normals unnecessary. Gotcha. Okay. Alright. It's all coming together. The object file might be compressed to share vertices, so the indices might be a bit funky. Well, I'm hoping that... Wait, what? Why does this face have 4... Oh, dude. Oh, dude. I think I downloaded a busted up object file. This is not good. This is 4 vertices per face. That's not good. Wait. I don't want to draw quads. I don't want to draw quads at all. Dude. That's crazy. Enjoy. No. I didn't want this to happen. I'm gonna have to download Blender or something. Well, I want them to preserve whatever clockwiseness. Or, no. You know which... Wait. Vertices are stored in counterclockwise order. So, like... there might be only one way to unpack it. Like if I do 92, 96, 97. Wait, no, that doesn't make any sense. Okay, actually, yeah, we can work with this. We can totally decode the quads for sure. I think we can do that. I think if this object file isn't totally busted, and the vertices are stored in counterclockwise order. Oh my god. There, we're back here. Blah blah blah. One with the first 3 indices and one with the first, 3rd, and 4th. If you have 0, 1, 2, and 3. Which are counterclockwise. You'd have 0, 1, 2. And you would have 0, 2, 3. Like, you always want the vertex to be ascending. The vertex index to be ascending. You keep sniping it. Too good. Too good. Okay, so taking one of these for example. I don't like how it orders these vertices. It goes 81, 80, 95. We're gonna get it. I feel like we can get it looking really good within the next, like, 30 minutes. We just have to untangle this quad BS. Okay, well, if I try to be clever about this. Hang on, I need to open up Paint. Oh. Okay, Paint just isn't displaying for some reason. Why does Paint look like this? There we go. Paint.net. Alright, this is crazy. I assume that it's like... '82, 81. I really don't know what it intends. Well, let's assume that it just... I don't know what this object file wants. Like, does it want me to do it like this? That doesn't make any sense. What am I stuck on? So I started rendering this Star Fox spaceship, but then I realized that I wasn't fully rendering it because I'm only rendering the triangles that were in this file, but the file also has squares. It has rectangles, quads, that I was totally skipping over. So I'm just missing a bunch of geometry. 82, 81, 96. 82, 81, 96. And 82, 96, 97. Yeah, okay. I'm just gonna do that then. Yeah, alright. We're gonna see what happens. So before we even do any of the dot product stuff, to go to my model loader. So now I actually have to check. I have to check if there's, excuse me. I have to check if there's 4 vertices instead of 3. Function returns the number of items in the argument list successfully filled. This count can match the expected number or be less in case of a matching failure. Huh. Well, that's interesting. Alright, we're just learning about C. Jesus. Beautiful. Let me just double check what we get for this thing. Okay, so sometimes we get 6 numbers, sometimes we get 8 numbers. Cool. So I can just say if result is equal to 8, we're doing a quad. Quad time. Yeah. Okay. And so I just want to pull out 2 triangles is all. Oh, this is totally crap. This is really bad. This is awful. You. This is the most disgusting function I've ever written in my life. Sure that's still works. Okay. There's really that many quads? That's crazy. Okay, so the way I've been doing it has been like this. I only get one triangles. And it renders okay. But I actually want 2 triangles. So the assumption we're making is that we actually want to do this triangle as well. It does look more filled in. Actually, yeah, I think that was good. I think that was okay. Yeah. You can totally see that it's filling in the quads now. Okay. Sure. Yeah, sure, why not? So now we'll get the normal. And then, like, dot product the normal with the light source, the direction of the camera, which is the cosine of the angle of the whatever, and then we'll multiply everything and it'll be beautiful. Right, I just gotta take these 3 points and do a little, yeah, the edges, a little cross product of them. I have to know how to implement a cross product. Dude, I don't know. I truly don't know. Yeah, right hand rule. Yeah, you're right. A cross B is this guy. Okay. I'm just gonna look up what's the equation for cross product. I just need the equation. A2 times B3 minus A3 times B2. There's definitely some kind of intuition behind this. But I just want to use this as a tool. I'm not trying to learn exactly the intuition behind it. Just need to know how to use it. I assume this is not lying to me. I assume it's this equation. Yeah, that's what they're doing. So yeah, A2 times B3. Okay, all right. I'm into it. I can do it. It looks so random. A dot Z times B dot X. They didn't even... This isn't even complete. I have a typo. I think they meant A1 there. We're gonna find out. It's just a perpendicular calculation. I feel like I learned that at one point. This feels right. All of these vector formulas have like this weird symmetry to them. It is beautiful. I'll admit, it is beautiful. In a kind of like a horrific, like Lovecraftian way. Anyway, there's our cross and our sub. What were we doing? We need to get the normal. Okay. Right. So we get the first edge, which is v2 minus v1. Make sure I'm doing this right. So these are my 2D coordinates. I want this. These are my rotated little guys. Edge 2 is U. We get the cross product. I assume order matters. I don't think it's commutative. E1 minus E2. And then the normal, we actually have to divide it by its length because it could be whatever freaking length. But we don't care about the length of the normal, we just, right? Do we? No, we don't need to divide it by its length because we're just doing a dot product. We're just finding the angle between the two vectors. We don't care about the length of the vectors. See, I know some linear algebra. I know a little bit. Not a vector 3. Okay, so what am I doing here? What did I call it? This is very similar to what I was doing for this ray tracing application. So what am I doing here? I'm doing the dot product between our normal and the face normal and the camera whatever. Light or something. And I'm just gonna say light is just going straight forward. Yeah, I might want to do negative value here, but we're gonna find out. Okay. Guys, we're so close. We're so close to something awesome. We're so close. Okay, and then the color, get rid of this dog shit color function. Let's just do this. So let me think here. This is the cosine of an angle, which goes from -1 to 1. So at most, this is going to be full white, and if it's negative, we want it to be 0. Yeah, okay. Actually, if it's negative, we'll just coal the triangle. That's backface coaling. Oh my god. So that's what it is. Guys, we're learning. We're learning so much. Alright, I haven't run it in a while, let's just run it. It's invisible. Alright, alright. Let me think here. This dot product is interesting because these first two components are 0. So I'm really just multiplying the Z position by 1. Oh, dude. I just remembered. Stupid. I forgot my linear algebra. Get out of here. I knew this. I learned this before. What the fuck is this? When they do that cosine angle thing, it's not just a dot b, you have to divide it by both their lengths. So I still have to divide this by both of their lengths. Alright, alright. Well, I also want, like, the angle will tell me how bright to render the triangle. Yeah. You're right, I needed to divide by the, you know, their lengths. That's awesome. or... This is how you do it, right? What am I doing? I promise you, we're gonna get this. We're like so close, dude. I bet I could do it in 7 minutes. I bet we can get there in 7 minutes. If I... You can tell I'm getting tired. I'm making a lot of typos. Okay. Okay. It's still blank, but it's more accurate. It's more accurate. Let me just make sure that did I do something crazy? Let me make sure I just didn't do anything really weird. It's just not filling the triangles. Oh, dude, because we're returning. I bet that's why. Okay, good. We're still alive. But for some reason, we're always getting a negative number, which is pretty cool. It's pretty surprising that all of them are negative. What the fuck? Oh, dude. This is what happens at 3 a.m. at 3:40 a.m. Good lord. Or continue. I think you're tired too. I think we're both tired. There we go. Alright. There's clearly something wrong here. What kind of values are we getting? Okay, basically only -1 and 1 and nan, which is awesome. No, that's impressive. That's impressive. It's interesting that we only get 1 and -1 in nan. That's actually pretty surprising. Because, like, the math here is all, like, pretty much correct. Get the first edge. The second edge, we do the cross product. Classic. Gives us the normal. And then we dot the thing. You know, I could have messed up at any of these points. X, X, Y, Y. 8 dot C plus times B dot C. Okay, everything looks okay. It is 3:42 a.m. for me. Find out. We're so close. Like, it is tantalizing. I'm being tantalized right now. Can't handle it. Like, we are edging right now. You know what I mean? Edge 1, edge 2. That's good enough. Yeah, just pretty normal numbers here. It's interesting that the Z component is always 0. Why would that be? Why would... I'm not projecting it yet. Rasterization Goon Cave. This is... Welcome. Maybe it's just working. Maybe it. Well, no, it's not, because we're not getting intermediate values here. It's just like it's only 1 and -1. That's nonsense. So the Z component was always 0 for some reason, which is kind of weird. I'll admit, that's kind of strange. Like, maybe I just didn't look at enough. No, it's like always 0. That don't make no sense. That don't make any sense. What if my rotation function is just killing it? Or not you? Okay, well now we get numbers. Oh, well that's weird. You'd think with angle 0 this would just be the identity. But no. Dude. How long is it? How did it work before? What? It was literally, it was rotating before. Why was it? Oh my god. Mixing up my sines and cosines. Amateur. What? I don't understand. It looked like it was rotating before. That's so weird. Okay, it's still ass. But you know, it's better. Maybe we're getting actual values. Okay, beautiful. Oh, okay, we're getting numbers. Great. Numbers even. Okay, so now it should change the brightness. Excuse me? I'm doing something crazy here. There's like there's just... Dude. Okay. Actually, I know why it looks like that. It's not supposed to look like that. Hang on. Oh my god. Don't be purple. I forgot how many bits I was working with. Okay. Let's rotate it. Fuck it. See if our back face calling is... You know? Wait, that's kind of funny. It's not rendering the little fox guy. Because he's inside the cockpit. Right? And so he's getting cold. This is crazy. This looks better. I think... This is okay. So... This is still okay. No, I think this is it. So I think it is doing backface culling. It's just, there's so many front faces, you know? And this is like a super complicated shape. So I think it's correctly rendering all of the front faces. Maybe. I mean, it's kind of weird that it gets really dark when you look at it from the front. I don't know why it does it like that. And then for some reason it gets really bright when you look at it from the side. There's yeah. Yeah. Actually, I can't even tell which way this is rotating, to be honest. This is like that one illusion. Now, why does it get dark when looking at it from the front? I don't know. Let's download some OBJ files. objfiles.com. What's a good 3D model? Let's do, what is it called? Here's another OBJ. Oh. It's got a different format. That's awesome. That's really cool. Might just have to tokenize it. Yeah, this one is textured. Well. I think this is looking right. Okay, I think actually it makes sense why it's so dark from the front, because it's so pointy. It's so pointy that all of these normals are like perpendicular to the camera. I think we're doing it right. Maybe. Like, we're getting a lot of this happening. Well, shoot. Should I wrap up or should I keep going? Maybe I should learn about Z-buffering. Okay, it can't be that hard to implement a Z-buffer, right? Just make a buffer and then, you know, tell it what the Z is. But actually, I think I have to know what the barycentric coordinates are. Like, this means that when I render a triangle, I have to convert the pixels on the triangle back to their actual z-coordinate. Well, that can't be too hard. Maybe I should go to bed. My brain, I think it's clear that my brain is not ready to continue with a bunch of 3D math, but I'm so tempted. So when I'm drawing a triangle now, I only give it the 2D coordinates. But I would love to know whatever the z-coordinate for each pixel is. Well, that's not, I don't think that's too hard. I just need to, like, intersect. Like, if I just shoot a ray... Hang on. I don't want to do ray tracing. If I just shoot a ray from every pixel on the screen, I can rasterize the triangle. Alright, I'll go to bed. I'm not gonna try to reinvent Z-buffers at 4 AM. It's just gonna turn into... I'm just gonna end up trying to ray trace it and then everything is gonna fall apart. But I'm pretty happy with this so far. This is looking promising. We just gotta give it a good Z buffer and then actually project it into 3D space. And then we're good. That's the renderer. Thank you. Yeah, really glad you stopped by. Honestly, I would not have made much progress if I weren't rubber ducking with you, so very, very happy you were here along for the ride. Alright. Thanks to other folks who stuck around. And yeah, we'll make more progress on this. Probably tomorrow. I'll see you guys later.